Today we're going to start talking about transformations. Now, transformation is a general term that applies to all kinds of different changes in a graph. There's three specific kinds of transformations that we're going to discuss this term, and the first one is called a translation. Sometimes you'll hear translations referred to as slides. Before we start looking at actual translations, we need to know pre-image and image. A pre-image refers to any object, and this can be a point, a line segment, a polygon, really any object on a graph before a transformation has taken place. And of course, we name those points and lines and polygons by regular uppercase letters, right? A, B, C, and so on. Well, an image refers to that exact same object after the transformation has happened. And notice the change in notation. We change our original points and put a little prime symbol on them, A prime, B prime, C prime, and so on, so that we know the difference between our original object or our pre-image and our new object called the image. We also need to know some of the notation you'll see in this unit. And this is called arrow notation, hopefully for obvious reasons. But sometimes you'll see that arrow replaced with an equal sign, and that's okay. It means the same thing. But this notation tells me I'm going to take every point x, y, and I'm going to change it. And I'm going to add some value h to every x value, and some value k to every y value. You also see this notation sometimes with a capital T in front. T, of course, stands for translation. And sometimes you'll see it shortened even more with capital T subscript h comma k. That gives us the values that we're going to add to add to x and add to y. There's only 4 directions you can move in a translation. Of course, left, right, up, and down. And that sounds really basic, but I'm going to add some notation on here to kind of help us with some translations. Our x-axis, of course, is the horizontal axis. And when we add a value to x, we're going to move to the right. And when we subtract from x, of course, we're going to move left. Our y-axis is vertical, and when you add to y, you're going to move up, and when you subtract from y, you're going to move down. And sometimes you'll have more than one change in value. Sometimes you'll go left and up. Sometimes you'll go right and down. You can have lots of different combinations here in a translation. So we're going to start, first of all, with a single point A. And we're actually given the arrow notation, and we're told to translate this point. Well, this translation tells us to subtract 10 from the x value and subtract 8 from the y value. Well, subtracting from our x value tells us to move left 10 units, and subtracting 8 from the y value tells us to move down 8. So in words, this translation is left 10, down 8. And I forgot to show you the shortened notation for that translation. So now let's actually do the transformation on this point. Subtracting 10 from x, we're going to move to the left 10 units. Then we're going to move down 8 units. And that's where we're going to place our new point, and we're going to call that new translated point A prime. If we look at the coordinates of our new points, I actually could have done the entire transformation just using the coordinates. Because our original point was at 7, 6. 7 subtract 10 is -3. And 6 subtract 8 is -2. And then I could have just plotted my new point A prime at -3, -2. Either way is totally appropriate. Now let's take a look at a different graph. This one has triangles, and you actually see the original triangle and our new translated triangle. And again, you can tell the difference between the two figures because in the triangle on the left we see ABC, and in the triangle on the right we have A prime, B prime, and C prime, and that tells us that this is our figure after translation. So we're going to focus first just on point A, and we're going to look at what translation has actually happened here. Remember, we can only move up, down, left, and right. We can't move at a diagonal. So to get from point A to point A prime, it looks like we moved to the right 12 units, and then we moved down 7 units. Remember, when we move down, that's in a negative motion. And it's actually the same with all 3 points, and it should be the exact same translation for all points, for all vertices in our graph. So I'm going to start by writing that translation in words. We went to the right 12 units and down 7, so right 12, down 7. If I want to write that in arrow notation, I'm going to translate every point xy and change it so that I'm adding 12 to every x. That means I'm going to move to the right 12. And I'm going to subtract 7 from every y value, or move down 7 units. The shortened notation that you'll see sometimes is t sub 12 comma negative 7. Again, if I look at the coordinates, a lot of times you can actually do the whole translation just by looking at the coordinates. If I look at my original points and my new translated points, my pre-image and my image points, you can see that adding 12 and subtracting 7. Negative 5 plus 12 is 7. 5 minus 7 is negative 2. Same thing happens in points B and C. Let's move on to our next translation. We're going to do the same thing in this graph as we did in our last one, but I just wanted to show you this graph because you really do need to be careful to identify which object is your pre-image and which object is your image. One of the most common mistakes that students make is always assuming that the figure on the left is the pre-image, when we can see that that's not the case. ABC is now in the figure to the right, and A prime, B prime, C prime is our new image on the left. So again, we're just going to focus on one point, and this time I'm going to focus on point B. Moving from B to B prime, I had to move to the left 10 units and then down 4 units. Remember, left and down is always moving in negative directions. And it's, again, the same for all 3 points. So in words, I can write that translation as left 10, down 4. But in arrow notation, I need to say the translation of all points xy are such, and this time I use the equal sign instead of the arrow, such that we're going to subtract 10 from every x and subtract 4 from every y. So the translation of xy equals x minus 10 comma y minus 4. And here's the shortened translation notation. Again, I can find the coordinates of my new image by using the subtract 10 and the subtract 4. Subtracting 10 from every x and subtracting 4 from every y, I can find the coordinates of our new image and do the translation that way. And sometimes you'll actually be given the original points and be asked to find the new translated points without even having a graph. So you definitely need to know what the notation is telling you to do. Finally, it is possible to have more than one translation that takes place in a graph. So if I start with point 7, 2, point P that's located at 7, 2, I can actually see that in my translation notation, there's two translations that need to take place. Just like with any type of math, I'm going to start with the one that's in the parentheses first. So I need to add 3 to my x value 7, and I need to add 5 to my y value of 2. That means that point P prime, my first translation, is going to be at 10, 7. When I do the second translation, I'm going to have to add another prime to our original P prime to show that a second translation has taken place, and I'm going to call that new point P double prime. So when I add 2 to 10, I'm going to get 12. When I subtract 1 from 7, I'm going to get 6. And my new point, my final image, P double prime, is going to be at 12, 6. Just so you know, in case you're ever asked to do more than one translation at a time. Just a quick reminder, a translation is one type of transformation. Arrow notation shows the movement of each and every point from the pre-image to the image, and another word for translation is slide. That wraps up today's lesson. I hope you have a great day, and I'll see you next time.